Hey everybody, today we're going to go over the content for section 2-3. Actually it's 2-3, 2-4 I guess, but we'll call it 2-3. And it's all about a combination of a few things. It's the equations you need to work with lines, and it's related to the previous content about parallel lines and transversals. So there's a few things we're going to talk about today. We're going to talk about the slope formula. We're going to talk about the slope-intercept form. We're going to talk about point-slope form. We're going to talk about how you're able to manipulate these things and basically get information from these things. So that's the plan for today. I'm going to work my way through the odds for you, and then I'm going to need you guys to go ahead and do the evens on your own and then post that to Google Classroom. I'm going to give you an extra day because it's a fairly large assignment, so I'm going to give you an extra day to do that. Excuse me. And this video might take a little longer than usual, but I have a bathroom duty in 20 minutes, so we'll see if I can get that done before I get down there to lock down the bathrooms, I guess. So, number one, first of all, let's look at these formulas. This should look familiar to you. I'm going to zoom in a little bit. These should look very familiar to you. Slope formula. I'm also going to use the term rate of change. I actually like that term better than slope. They both mean the same thing, but rate of change is a term you'll see used further on down the line in different math courses, and I actually think it's a better term to use. But anyway, slope formula, also known as the rate of change formula, slope-intercept form, and then point-slope form. So let's go ahead and start our way here. So it says write the equations of the lines given the following information. So we want to write it in slope-intercept form, which is y equals mx plus b, right? M being the rate of change, b being the y-intercept. And they give us the slope and they give us the y-intercept. So really straightforward. This will become our m. This will become our b. And we're going to go ahead and plug those in. So we're going to say y equals 5/3 x minus 4. You can write plus a negative 4, but you don't really need to. Here, we're going to write this in point-slope form. And they give us point-slope form. We're going to write it in slope-intercept form. So we want to change this to be y equals mx plus b. So let's go ahead and manipulate this. So not a lot of room, so I might have to write kind of small. We'll see how I do here. So we're going to go ahead and start with distribution. So we're going to distribute this negative 7/5. We're going to have y minus 5. Oop, I'm going to slide over so you can see it. Y minus 5 equals negative 7/5 x, and then negative 7/5 times positive 5 would be negative 7. You'd get negative 35 over 5, and it's negative 7, or the 5s cancel out. All right, so we're almost there. We just want to get the y by itself here. So we're going to add 5 to both sides. So we're going to add 5 here, add 5 here, and I'm going to write it over here actually so that's more room. So these 5s cancel out, so y equals this negative 7/5 stays as is, and then negative 7 plus 5 would be negative 2. Okay, that's it. Now we're good to go. So let's look at this next part. So now we're given the slope and a point. So now we're given these. We're actually going to use the point-slope form, which is going to be y minus y1 equals m parentheses x minus x1. I would recommend writing this formula every time you do this, at least for a while, because what it does is it allows you to remember this. It just kind of like the repetition of writing this down really helps you remember this. And I know it only takes like 5 seconds to do it, so honestly I think it's well worth it. So we're going to start by labeling our points here, so x1, y1, or assigning our variables rather. That's going to be our m. So we just plug these in. So y minus, and what's our y1? Our y1 is negative 3, so we're going to put y minus negative 3. Be careful here, don't write y minus 3. A lot of people do that. They make the mistake of just forgetting that other negative sign, and we'll take care of that in a moment. Our m is going to be 1/2. Our x sub 1 is going to be 4, so minus 4. And now we go ahead and start getting y by itself. So first things first, we're going to rewrite this as x plus 3. And we're going to rewrite that on the next line. We're not going to like just combine those together. We're going to show the step here. That's another thing that's important. And it takes another line of writing to do so, but I think it's well worth it. So y plus 3 equals 1/2, and then parentheses x minus 4. So now we're going to go ahead and distribute that 1/2. So we have y plus 3 equals 1/2 x, and then half of negative 4 is negative 2. And then what we want to do is get y by itself, so we're going to subtract 3 from both sides. So we're going to get y y equals, I'm going to write over here so we have a little more room, 1/2 x, and then negative 2 minus 3 is negative 5. Okay, there we go. Let's do the same thing down here. So I'm going to write the equation again. So I'm going to write y minus y1 equals m parentheses x minus x1. Okay, I'm going to go ahead and assign my variables here, x1, y1, and m. And we're going to plug these in. So we're going to write y minus 5, and then m is going to be 2, and x minus 3, okay? And now we're going to go ahead and start simplifying this. So we're going to distribute this 2, so 2 times x, 2 times 3. So we're at y minus 5 equals 2x minus 6, and then we're going to add 5 to both sides. So we're going to have y equals 2x minus 1. And there we go. That concludes the first page. Okay, next page. They give us 2 points, and we have to write the equation of the line. So we're going to start with the slope formula. We're going to get the slope at rate of change, and then we're going to use one of these points. Now you could cheat and use this as your y-intercept, because this actually is the y-intercept, but we're not going to do that. We're going to go ahead and do the work here. But you could cheat if you wanted to, but we're not going to. So let's go ahead and plug these in. So again, our rate of change formula is y2 minus y1, or change in y over change in x, which I'm sure you've done this a billion times. So our y sub 2 is negative 4, minus our y sub 1 is negative 1. Our x sub 2 is 0. Our x, I totally just screwed that up. Pay no attention to that one. Okay, let's try that again. Y sub 2 is negative 4, minus our y sub 1 is 5. Okay, that's much better. There we go. And then x sub 2 is 0, minus negative 1. There you go. All right. Still there. Still got it. All right. Let's get rid of these double negatives. Let's change that to plus 1. We're going to go ahead and rewrite that. So we're going to have negative 4 minus 5 over 1. And then negative 4 minus 5 is, of course, negative 9 over 1. So that's our m. That's our rate of change. All right. So we have our rate of change. We have our x1, y1. So we can go ahead and plug these in. So let's go ahead and write the formula here. So y minus y1 equals m parentheses x minus x1. And now we're going to go ahead and plug these in. So our y sub 1 is going to be 5. Our m is negative 9. You can write negative 9 over 1, but it doesn't really matter. Our x sub 1 is negative 1. So again, remember, we have double negative here, so don't forget that. Do not fall into the trap of just writing x minus 1. So y minus 5 equals negative 9, x plus 1, and then we're going to distribute that negative 9. Okay? So y minus 5 equals negative 9x minus 9, and then we're going to add 5 to both sides. And y is equal to negative 9x minus 4. And that's our equation, okay? I'm not going to do these others because this should show you how to do all those, okay? So go ahead and go for that. Okay. I'm running a little tight on time. We'll see how much, we're going to try to get through everything, but I'm not going to be able to do as many as I think I wanted to. All right, so parallel lines. Parallel lines never intersect and have the same rate of change. Rate of change. We'll put parentheses slope. If the two lines are parallel, their slopes are identical. Okay. So write the equation of a line parallel and then graph both lines. So you don't have to graph the lines because if you're doing this at home, you probably won't have the graph paper. That's totally fine. Yeah, I just want you to write the equation of a line. So I'm going to get you started on this. I'm not going to do it for you because it's actually it's almost identical to what we just did. So they tell us the equation goes through this point and it's parallel to this line. If it's parallel to this line, that means it has the exact same rate of change, which in this case is negative 5. So this is our x1, this is our y1, and this would be our m. This would be our negative 5. You would just use these three values and do exactly what we did with really any of these. If you go back to, let's say, number 7, right? You could use that as a guide. That's our m, that's our x1, that's our y1. You plug it in the point slope form, and voila, you're able to find it. That's how you would solve these. Okay, you just identify the rate of change. You use that as your m, and then you use your x1, y1. Pretty straightforward. Okay, let's go to perpendicular lines. Perpendicular lines create 90-degree angles where they intersect. And this is the one that throws people off. Now, if two lines are perpendicular, there's a relationship between their slopes. And I like to call it what's an opposite inverse. By opposite inverse, I mean it has the opposite sign and it's inverted. Okay, so if you've heard the term multiplicative inverse, you might know where I'm coming from here. So if two lines are perpendicular, slopes are opposite inverses. Okay. Now I'll show you exactly what that means. So it says it goes through a point 3, -5, perpendicular to this. This should be 1/3. Okay, so this is our x1, y1. And it's not going to be the same. So if it was parallel, we'd say the m is 1/3. But because it's perpendicular to it, it means we take this number, okay, we flip it, and we change its sign. So 1/3 would become 3/1. So m would be 3/1, or just 3. And this is positive 1/3, so this would become -3. So you flip it and you change its sign, and that's all you have to do. So once you have the m, the x1, y1, you then go back, plug it into your point slope form, and you're good to go. And you just, you get the y by itself, and you're going to have slope intercept form in no time. So that's how you solve these 4 problems. Okay, I'm not going to do the whole thing. 1, because of time. 2, because I'm pretty sure we can do that without me showing you. Okay, and again, this should all be a review, but I wouldn't be surprised if I just forgot this stuff because it's been a while. All right, last part. It's going to ask you a few questions here. I'll go through a few of these. So state whether the lines are parallel, perpendicular, or neither. So there's a checklist you can follow here to make this easier for you. First of all, these are in slope-intercept form, which makes this a lot easier for us. All you want to do is really look at the rates of change of the slopes. Okay, first thing you want to see is, are they the same? This is 6, this is -1/6. They're definitely not the same, so it's not parallel. Okay, now that you've indicated they're different, are they opposite inverses? Yes, they are. They're opposite sign and they're inverted. So this would be perpendicular, okay? You're going to go through that checklist. If they weren't opposite inverse, but they were different, they would just be neither, okay? So for example, if this is 6x, let's just say this is like 1/3, then they'd be neither. They would be neither parallel nor perpendicular, okay? And here, it's just asking you which of the following lines is parallel to it. So obviously, if it's parallel, it's going to have the same rate of change. You just identify that. And then here, you're going to have to do something very similar to it for number 25. The last one is a similar question, only it's perpendicular. I'm not going to go through these because I want you guys to figure that out on your own. All right, so that is going to be the assignments for this section. I may put a little more up, but I doubt it. I think this is enough. But if I decide to put something up, it'll be by the end of the day today. It won't be due till Friday, okay? So please let me know if you have any questions. I hope that was helpful, and thanks for watching, guys.